Welcome to the introduction in R. This is the 6th video. Today we talk about the for loop and the while loop, how we use them alone and in combination. So have fun, like and subscribe, and I hope you learn something. So first we start again and remove all the stuff in our environment. Then we come to the first for loop. So for the for loop we need an the value n, or we could also use some value itself. But for this case we will generate an object n, which is an integer. Then we want a place where we can store our values, which will be a vector in this case. So we generate this particular vector, which has the length n. And then we come to the for loop itself. A for loop goes from this index e. So this is kind of the number of iterations. And with this number of iteration, we can also use it for an index. So this iteration will also be the iteration itself and the index. And for every time this for loop goes through, so for example, for e is equal to 1, we will draw from a normal distribution with the length, and we calculate the mean of all these particular values. So we have a vector which has the length n, which are generated through the normal distribution where we draw randomly. And then this mean of all the values we've drawn from the rnorm function will get inside of our vector v1. Print the number of iteration. Let's get back to the rnorm function. The rnorm function is a function which draws from a normal distribution. And if we take it by default, if we just put in the number of values we want to draw, then we have a normal distribution. In this case, we have a standard normal distribution, which means we have a mean of 0 and standard deviation of 1. Every time the for loop goes through, the e value will be printed out. So this is like the 930th iteration. And inside our vector, there should be all the values we have drawn. Okay, perfect. These are all the means of all the values we have drawn. And now let's have a look. These are all the means. We see, okay, that makes sense because we have drawn from a standard normal distribution. And they should center around the mean, the actual mean, like 0. So in this we can plot with the function plot, and then we can use applying to see where the mean of all those values is. And then we can use the actual true value, which is 0. And it will be inside. And this will be shown with the green line. So we see it's not exact, but the red line is somehow near the green line. For the next for loop, we will use the library datasets. And out of the library datasets, we get our dataset USArrest. Then we have a look at the structure. So inside of our data frame, there are the variables murder, assault, urban population, and rape. What we want to do now is calculate the mean of every of these columns. So in this time we don't use the apply function. We take a similar approach. We use the for loop instead. First we generate an object for all the objects we will get, and then we start a for loop. And so we see, first it will calculate the mean of the first column, then the second column, then the third, and then the fourth. That's why the second column for the first iteration isn't the actual mean, it is 0. So every time this for loop goes on, it will be stored. We cannot also use this kind of writing here. We also can write it a different way. It's with the sequence along function. So with the sequence along function, we can do the same thing. It will get us the same output as this, and it will look like that. And this is useful if we want to get if we have like different objects and we are not want to manually adjust every time we put a different object inside. So this is quite practical, because every time you put an object in, it will automatically see, okay, this is a different object and it has a different length. So we have to use a different kind of iteration, a different number of iterations. But in the end, we will have the same output. This is kind of a little bit more difficult approach, or it is a little bit more, you have to think a little bit more about it, because if you put two for loops together, we have to use different kind of iterations or different kind of objects for iterations. Because if we use always the same name, if we are using just E for the iterations for all the for loops, this value here will always be EE. So 1 1, 2 2, 3 3, 4 4. But we want all the values to be shown inside of this function print. So for this case, we need a different kind of name for iteration in the second for loop. So if we start like this, so we see the values will be the same after a certain number. After number 4, we have the same values again. That's what we want to adjust, because we want all the values inside here. So, and for that case, we are using E and G. It will go through like that. It will use first E as 1. Then it will use 1 1, 1 2, 1 3, 1 4. Then it will go back again, and it will use 2 1, 2 2, 2 3, 2 4, and so on. So we get all the values out of US. That's perfect. Always think about that. If you're making for loops inside of for loops, always use a different index or a different iteration name for all the for loops. Otherwise you have like complications. Then we do it that way, and we see it works out. So every time we do the for loop, there will be a different value inside. So that's quite nice. Okay, let's go to the while loop. The while loop is a different approach. It's kind of similar. You can do the same stuff with a while loop as with a for loop, but you cannot do the same stuff with a for loop what you want to do with a while loop. First, we have to get a vector where we can store our data. Then we have to generate an initial value. So, and here's the difference. The for loop is based on some integers, and the while loop is based on a condition. As long as this condition inside the brackets isn't satisfied, the while loop will go on. And so if O is smaller than 11, then this will go on. So every time it will sample out of this particular function, and every time the while loop go through, there will be 1 added to. In this case, it will work similar than a for loop. These should be like 10 values. Perfect. And what the while loop is very useful for is for difference. So if you have something which needs to converge, you can use a while loop. So you can put the converge criteria inside of the while loop, inside of the condition of the while loop. And so if a particular difference between the first value or some value next is reached, then the while loop will stop. And so in this case, we have the initial value for diff, which is the difference. And we will start with 1. And we have E for indicating our vector v4. As long as diff is greater than 1.01, this will go on. And then we have a look when it will reach the criteria. Okay, we have to generate these values first. So, perfect. And then we see, okay. we have a look at the vector itself. So, and we see it reaches the criteria at 29. Perfect. So, and this is like we store our values. We used a E for indicating. So E is saying, okay, this particular value should get inside of this storage element of the vector. Perfect. This is quite interesting if you have an algorithm which needs a converging criteria and you want to program it yourself. Then a while loop is very practical for that. So, and then we can also use the combination of both. So we can use for and while. So for this we generate a list. And what we want to do is we will indicate a list, and in each list element there should be a vector. And the vector should contain the difference between two normal drawn values of a normal distribution. So we generate our initial value. We generate the vector each time for each E inside of the for loop. Then as long as this criteria isn't satisfied, the vector will be stored with new values. And then in the end, when the criteria is satisfied, then this particular vector will be stored inside of a list. Let's do it. Okay, and we see it is not working properly because some list elements are empty. We want a vector inside of each of those list elements. So please pause the video and think about what you can do about it and make your own solution. I will go on now. You can pause it and think about it, and I will show you the solution. So the solution is we have indicated poorly because this E should be the indication of our list and not also for our vector, because then E is not going one after one. It's not going 1, 2, 3, 4, 5. It's going 1, 8, 16 or something, because we always add 1 to E and we don't recycle E. So we have to make sure that we have a different kind of indication and a different name for it. So we use G for our vector and we use E for our list. And now it will work, I promise. So, and this time you see, okay, inside of each of those list elements there is a vector. Perfect. So now what we want to do, we want to see how it looks in a plot for the first list element. We give it a main name and we give it a name to the labels on the X and Y axis. And so we see, okay, these are all of our points, and then we use the upline function inside of a for loop. And inside of this for loop, we want for all of the list elements of L, we want the mean of every list element in L. Every list element which is inside of L, so every vector, we compute the mean, and we will see it in this plot. No, okay. It will look like that. Okay. Okay, we see the difference is somehow between 1.2, I guess. But we see, okay, we have write the name a little bit. We have given it the wrong name because it shouldn't be list. It should be the actual difference. And this is like, let's call it X. Okay, these are the values on the X axis, and on the Y axis we should see the value of the difference. So let's do it right. Okay, perfect. Okay, we see it's somehow near that, and we have some extreme values and one really extreme value which is near 0. Okay, so that's for today's lesson. So I hope you learned something, and if you have some questions, please put it inside the comments, and like and subscribe to the channel, and see you next time.